Alrighty, good evening, everybody. Welcome to the second session for our Zero to Hero seminar series. This evening we have Nick Quigley again. He's going to be doing a presentation regarding the Bind9 DNS service. We'll talk about kind of what that does, and then we'll have the ability to then kind of follow along as we do a demonstration. So without further ado, Nick, the floor is yours.
Thank you. Thank you. All right. So let me just share the screen, get started with the presentation. All right, so as David has stated, that this is the Zero to Hero Defensive Seminar on domain name systems. So what is DNS? What is a domain name service? It's a service made to essentially help people actually use the internet. The networks communicate which computer is where and what service is running wherever using a system known as IP addressing. And an IP address is going to be a very hard to remember string of numbers. Either in IPv4, it's going to be 12 digits. IPv6, it's going to be a lot more digits. IPv6 is just a semi-recent updated version of IPv4. It has much more address space because IPv4 was made when they didn't think that many things would be connected to the internet, and then they ran out of address space. So DNS is essentially there so that you don't have to memorize every single IP address of sites you frequent or would like to go to. You can just remember something like wikipedia.org, google.com, iit.edu. And so it often gets called the phone book of the internet, so to speak, because it works in much the same way that a phone book allows you to just remember a name and then look up a number that you can actually use to contact someone. And it's not just websites. It's also email, any sort of internal subdomain you might have, so especially with printers. If you go to IIT, you might have seen the difference between @hawk.iit.edu and @iit.edu. Both of those, @hawk.iit.edu is a subdomain of hawk.edu that DNS, domain name services, takes care of. Now, in order to actually resolve that random host name you might have to not just any website, but the specific website you are trying to reach every single time, it has to go through a process that's a little bit complicated, but you do get used to it the more you interact with it. Well, the first thing that happens, of course, is a user request. You try and type in wikipedia.org /gorillas to find out your favorite fact about some sweet simians. And the step it'll take after that, before anything else, is what's known as checking its own cache. The cache in this case, refers to a small amount of permanent memory that your computer is going to keep just to remember very commonly accessed very commonly accessed websites. So if you visit wikipedia.com or .org and then close your tab, and then you try and open another browser to wikipedia.org, it doesn't have to go through the whole process again. It has a cache, it remembers it from the last time you tried it, and it'll just immediately boot you in there. It's not really part necessarily of the rest of it's a bit weird compared to the rest of the steps, which is why I put it as 1.5 rather than as step 2. But the first definitely DNS step for an uncached request is to a root name server. Now, root name servers are sort of part of the backbone of the internet. There's not many of them. I think there's like 13 in total in the world. And they are constantly dealing with random requests from everything from Wikipedia to Google to Fortnite.com. I'm not sure. Just any single website that someone doesn't have cached. Because these websites will not necessarily know where each website is. They are there simply to put it down the correct path. And it'll go down a hierarchy of essentially one domain to the next, to the next, to the next, until it gets to whatever specific site you are trying to get. As it goes down this hierarchy, it'll get closer and closer and closer until it reaches what's known as an authoritative name server. This can actually give an answer about what site is connected to this IP address or what IP address is connected to this site, and provide that to the requesting computer. Now, after that, the request is typically cached so that if you visit it again, it doesn't have to do this process over again, because, I mean, it is kind of complicated. You can speed things up quite a bit by just remembering things. It's a bit of a rule of thumb. We can do this sometimes to help speed it up 50, 60%. I don't know the actual numbers there, but it might feel a little weird. It felt a little weird to me with caching. It's just there because it can be done. Now, that hierarchy is sort of specific. It starts, as we're discussing, at the root name server, one of only a couple servers in the world, and they will point you to one of a few top-level domains. Now, when you type in a website, it's going to be something like www. or en.wikipedia.org. That's sort of read right to left in terms of top down. When you type that in, the .org signifies that en.wikipedia.org falls within the .org top level domain. There's also a .com, a .net, a .edu, a .gov, all sorts of them. That will be able to tell you, much like how the root name server can tell you which top level domain, they'll be able to tell you which domain below them you're able to reach. And they're able to do this because you actually, when you put a site on the internet and you actually want some sort of domain name, you actually have to contact them and theoretically buy a domain or register a domain to use, such as Wikipedia from the .org domain or Google from the .com domain. And from there, Wikipedia.org has a whole bunch of different subdomains. They have their English language site on en.wikipedia.org, but they also have French on fr.wikipedia.org. They have German on de.wikipedia.org, for all sorts of languages. And here, Wikipedia.org is actually going to have their own DNS server that they use to route people looking for a specific language subdomain to that proper domain. Now, once it gets to en.wikipedia.org's authoritative name server, which is going to be the DNS server that states, here is the IP address that en.wikipedia.org is, it'll then take that IP address and send it back to the requesting computer. So that does sort of beg the question, if it's this sort of big global process, is it really that important why we have one on a local network? I mean, sure, you know, unless we're hosting a site, then it's important, but it seems to be a little bit unnecessary because a lot of that architecture is already out there. You might have heard of a few famous DNS servers. Have you ever heard references to 8.8.8.8 or 8.8.4.4? Those are very famous DNS resolvers. There's a lot of public-facing DNS services that are just there to facilitate that crawling of the hierarchy, even if you don't have a local DNS server. But you might want one. Number one, the most obvious reason is just because you might be hosting a site. You might be wikipedia.org, and you want to be able to serve people the English language or the French language or the German language or the Spanish language, or, you know. In addition to this, it can also improve performance primarily through that caching mechanism, because this way it's caching not just for individual computers here and there, but for an entire network. It also helps with redundancy and availability. If you know it's there because it's in your building or in your cloud, then, you know, I mean, that goes a long way in peace of mind. And it also helps reduce internet traffic because, you know, you don't have to be competing with other people for a public DNS server. That doesn't really matter if you're, you know, some small mom and pop shop, but if you're a large corporation, that is going to be a significant difference. And so from here, with that basic explanation, if anyone has any questions, now would be the time to ask them, because otherwise I'd like to switch to the lab environment to start setting up our own DNS server on our own networks. All right, so I'm not seeing any questions, so I figure we'll just move to the environment. Hold on, I need to type in my super secure password. Let me share my screen again to the Proxmox virtual environment. And we're going to be starting with our DNS serve IP. This is going to be on a flavor of Linux known as CentOS. You'll see it pretty commonly, I think, in competition environments. Was the standard for which Linux was taught in the CompTIA Linux exam. It's very bare bones. It does not have, in our capacity, a graphical user interface. So we are not going to be able to, use, mouse, files, folders, right? Everything has to be done via the command line, which can be very intimidating, but it really is an issue of you just have to do it over and over again, and you will become a lot better at it. It will become much more natural to use the command line than anything else. Plus, not a lot of servers are going to bother supporting a GUI. I mean, if you want this to actually act as a server to do something, serve up web pages, you don't want to be bothered with things like backgrounds or desktops or icons. So we're going to log in directly here. Clicking on the machine to the root user. And what's the password? Right. Very securely, DNS with a capital P password. All right, and that'll log us in. You can see that at root at localhost. You can ask, who am I? We're root. Where am I? It has no answer. There is a where am I command, but it's pwd, present working directory. We're in the /root user folder. And if we try and list what we see using the ls command, we're not going to see much because they wouldn't really populate a user on a server with much at all because it's, again, not very necessary. Now, we've already installed bind and the bind utilities onto this machine, just that we didn't have to bother with internet connections. But if you hadn't, you'd have to use a package manager to just download it on, yourself. Which I believe CentOS would be yum install bind-utils. You might not know that off the back of your hand. You just look up how to install XYZ on CentOS, Debian, Kali. There tends to be a lot of resources out there for these types of things. Now, because we've already downloaded it, we're going to go directly into what's known as making a zone file. Now, we have these two web pages up. One with Webster development with password webdev1, capital W, capital D. And the other our second web server with Webert Developmonte. Much like the first one, web dev, but this time with a 2. Now we're going to open up the terminal here. This is Debian 11. It does actually have a GUI interface, but we can't really do much with it in terms of what we want to do. So we're going to just open up the terminal and issue commands from there. Now, the first thing I'd like to do is just check on the status of, we downloaded what's known as Nginx, which is a web software, a web server software that allows you to create a website. And we can check to see if it's on using system control, which is systemctl, all one word. And system control allows us to issue multiple subcommands. You can consider them. The first will be status, to check the status of this Nginx service. And we can see it is actively running. Now, this was set up beforehand, but just to see what it's doing, we'll check out our own IP address, 192.168.2.2. Let's go to a web browser. One 192.168.2.2. Now that's that IP address. That'd be difficult to remember for all the websites you want to visit. You'd rather just use some other, some string that you could actually remember, that you could associate with the site. So here we see it's hosting a web server of our secret CyberWater recipe. This is for our CyberWater business that we are going to be selling to try and turn a profit. This is our business. Assume it's profitable. And we also have the DNS web server. I believe, if I were to guess, that'd just be running on the next number down or up. Yep. So here we have our main page we want people to see, to get them to try and buy CyberWater for $4.90. We give them a number to call. It's very basic. It's not a complicated website at all. It's not like a real storefront. The basic idea is we want both of these connected to the CyberWater domain. We want all our chefs out there who are actually making the CyberWater, be able to reference the very complex recipe. And we want our customers to be able to see the CyberWater buying page so that they'll actually find and then buy our product. And once again, this page is running on this DNS Web 2 server. It is, we just kept it to, generally speaking, you can only run like one website per server, but you can get a little bit screwy with it. In any capacity, we're going to essentially be setting up our DNS server such that we can actually have one of them act as something along the lines of shop.cyberwater.com and the other as recipe.cyberwater.com or anything else. Now, in order to do this, let's first check on the status of our bind 9 DNS system. We've already downloaded it, but I actually don't know if it's running. So once again, we'll use that system control command, systemctl status, and then instead of bind, which is the name of the software package, the actual service, the thing that's running, is referred to as named. Now that might be a little bit weird. It's not named, it's not past tense. It is name, as in domain name services, D. The D stands for daemon. If you think about how programs work, especially in Linux, it seems like it'd be start, and then it'd stop, start, stop one at a time. Like if we had a bunch of Python scripts in our in this machine, we would just be running, we could run one, then we could run the other, then we could run the first one, then we could run whichever other one. But sometimes we want programs to be running pretty much continuously in the background. These get a special name. They're called daemons or daemons. They're used for things like web servers, things you want to listen, things you want listening on the internet, for a DNS server, for our web servers, countless other things, for anything that you just want constantly running in the background. So the first thing we're going to do is just start the named service. Actually, no, sorry. First thing we're going to do is configure the bind9 service. So configuring bind is fairly straightforward. It's got a couple of files. You got to indicate, who you are, what zones you want, what names you want to give them. So we're going to navigate to that service by going to the change directory, cd/ect, for files that change sometimes, but not all that often, / and you might have seen this sort of auto-filling we have. If you hit tab, it'll try and fill it to the best of its ability. If it's not entirely sure, it'll go until it's sure. So like if you have image 1, image 2, image 3 in a directory, and you type in I and then hit tab, it'll fill to image, but it won't know which image specifically you want. If you double tap tab, it'll tell you everything that's there. So we're going to change directory into that etc directory, and then we are going to use vi to open up the named.conf file. Now, vi is one of many text editors in Linux. You'll hear a lot about things like Nano, vim, which is vi improved, Mousepad. There's a whole bunch of them. Vi is generally regarded as the most frustrating because a lot of these programs weren't made with regards to our modern understanding of how a text editor should work. This made perfect sense to the guy who made it. I'm not sure who that is, but whenever they made it. So it doesn't work as you'd expect it to. You might notice you can sort of navigate around with the arrow keys on this page, and you can go forward and backward. But if you try and type something in, it's a little bit weird. It might do strange things. It might not react as you expect. But that's because bind isn't necessarily, vi isn't necessarily in the proper mode. So vi can be in different modes. There's command mode and insertion mode, recording mode. Insertion mode is one we want to get into. So before we do anything else, you just hit I. Then you're in insertion mode, and then you can type things in. If you want to get out of insertion mode, you can't just close a file, Control-S, Control-C. That will actually get you stuck in VI. You hit the escape key first to get out of insert, and then if we wanted to write anything, we have to enter into the command mode by typing a semicolon. And it's a little small, but you'll see that semicolon right at the bottom there. And then we'll type in our one-letter commands. So the first one is going to be W for write. This is going to save it. But you can also do WQ. Q stands for quit. You could just use it on its own and it'll quit the program, or you could use it with write to save and exit. And once again, you see, we're back in the command line, outside in the outside directory, doing whatever we'd like. So I just hit ls, we can go hello. But to get back into the configuration file, we're going to, again, vi bind.conf or named.conf. We're going to change a few of these settings. So these are the default settings that the creators of bind gave to us, basically just, for testing so that it's not going to instantly run and be insecure or, something along those lines. but we're going to get into insert. And the first thing we are going to do is this listen on port. So the way this is going to work is that DNS is going to essentially be listening for something, for a request, for a query, for you trying to find wikipedia.org. And this is basically stating it's only going to listen on this IP address, which is sort of there's some reserved IP addresses. 127.0.0.1 is a loopback address. It just goes back to your computer. 127.0.0.1 is basically just a fancy name for you. So what this is saying is it's only listening on this port 53, but only for its own IP address. That's not really what we want. We also want the rest of everyone to, we want the rest of our network to be listening on that port. So if we want to be insecure, YOLO sec, we just commented out with a hashtag, with a octathorpe. But that's not secure. That would mean that, it's listening for anyone's queries, which might be fine, but we don't want anyone using it. This is for our domain. We don't want them having it. So instead, we are going to use what's known as CIDR notation to indicate our own network. CIDR is just a special way of indicating IP addresses. It's, IP addressing, it tends to follow blocks. So there's R192.168 dot something to something. We might start it at .2 and then just increment that last digit. So it's 192.168.2.1.2.2.3. And an easy way to indicate this is just by typing in 192.168 to indicate, this is sort of the basic block. .0.0/24, I believe it'd be. Yeah. And what this basically states is that this is correct for anything up to 192.168. Whatever. Anything else in there, we don't care. We don't care about that. We have everything from that minimum of 192.168.0.0 up until one of these 168 digits change. Now, you'll also see listen on v6, that is referring to IPv6, which is that an improved, expanded IP addressing system that people are trying to move to, but very slowly and maybe never. But we aren't really using v6 because it's kind of complicated, very hard to work with. So we're just going to comment it out. All right. Everything else in here, you'll see this zone. We're going to be making one of these zones for our CyberWater domain. So we want to sell cyberwater.com, right? We're going to make our own zone. We're going to go to the end here, still in insert mode. We're going to just hit enter and then zone, much like we have up here. We're going to indicate what our zone actually is, cyberwater.com. Because we are selling a profitable thing. And we are going to hit some curly brackets there. And again, much like you see in this zone file here for the hints, which is basically just an example zone file, we are going to do type master. It's basically just indicates we are the authoritative zone for this. This is like, we are the ones saying what this is. From there, you're going to indicate a file. We'll get to this later. So for now, we'll just fill it in with change me /change me because we haven't actually made this file yet. It's going to be what's known as a zone file. A zone being essentially something to give that authoritative name away, something to actually answer the DNS query. And of course, we'll end it with a semicolon. We always love semicolons. Something else we're going to be doing here, we're going to be hitting allow-query. Now, this means essentially that we're not just going to let anyone query our DNS server. We're going to restrict it in much the same way we restricted the listen on port configuration option. So we're just going to do, what is it, 198. .198.168.0.0./24.
Oh, sorry to interrupt there, Nick. I think in terms of the way that it's set up in the network, it's actually a .2, 168.2.0. Sorry about that. Yep. No, you're good. Yeah.
Thank you for letting me
change.
know.
Yeah, no, you're good.
And we got to hit, the end of that also has to have its own little semicolon. Semicolon here, semicolon here. Now, there is a way to check the syntax to make sure we're not just hoping that it works. And we'll show that command. All right, so for now, this is good. We're going to save it, not by hitting Control S, because that'll get you locked out of, not locked out, but in a way that it feels like you're getting locked out. If you do hit Q, and you should be able to get back in, but just hit Escape, colon, W for write, Q for quit, enter. And if we try and get back into there, we can just read it out by saying cat name.conf. We see our change is stuck. Great stuff. Now let's make that zone 5. So if we go change directories / etc. for files that don't change often but do change, / name for the DNS name service, name D being the daemon of that service, looking for its directory, we will see it's empty. There's nothing in here. It has this name D directory, but there's nothing in there. That's because this is a place for zone files, and we haven't made any zone files yet. So we just got to make our own. And unfortunately, examples are not easily present within CentOS or Bind9 systems, so we sort of have to make it from scratch. So VI, to, use that VI editor, we can just essentially call into being text page. So like if you call in text page that doesn't currently exist, it's just going to make its own. So VI / etc. for files that don't change much. For name D, for the name D files that will not change much. And then we're going to call it whatever our domain is going to be. So for us, that's going to be cyberwater.com.zone, because it is a .zone file. It's a .zone file referring to cyberwater.com. Hence why we call it cyberwater.com.zone. And you'll see we have a brand new empty page. And so we basically just got to fill it out. It's sort of hard to motivate, how you work this, but the best I could say is there's a lot of resources online to, sort of build your own examples. But unfortunately, you can't copy paste into the Proxmox machines, which is unfortunate. But for example, there's something known as a hostname file, a hosts file, that used to exist before DNS was really, everywhere and working. Basically, it was just a small file they'd have for people to connect an IP address and then give it a name. IP address, give it a name, one by one. And they'd have to do it manually. And a lot of times organizations just assign someone to manage that list. And it was not a very effective solution. But there are a lot of places that you can drum up a very basic zone file by converting a host file that you would make for your domain into this. But just to start on this, we're going to start by announcing what is going to be, well, first we're going to hit I to get into insert. What is going to be the time to live, TTL. This is how long the actual query that we send out for anything is actually going to live. And it's going to be some value in seconds, 86,400. You can make that longer, shorter. That's sort of the default. And we are going to announce this is the cyberwater.com. And we're actually going to add this little dot at the end too. Whenever you type in any sort of website like wikipedia.com, you don't include that dot at the end of com, but it's sort of just filtered in there. It's assumed, but it does technically exist. Because again, we're reading this sort of backwards. Cyberwater dot is a subdomain of com dot. So it'd be weird if the top level domains truly didn't have a dot. We just ignore it because why wouldn't we? No one wants to say com.net.gov. They'll just stop saying the dot at the end because it's the same for everyone. That's exactly what happens. So then we're going to hit tab to tab over some amount of spaces so that it'll get nice and readable. We're going to announce that this is an internet service record. There are other service records, but they're very, very niche. There's a chaos service record type. You're pretty much only ever going to deal with IN service record types. So I don't want to spend too much time talking about them. This basically just means this is for a network. We're making a domain for a network. And we are going to hit SOA. This means start of authority. It indicates that we are the authoritative name server for it. And we are going to call in nameserver1.cyberwater.com. This is the DNS machine that is actually going to give the authoritative answers. We haven't made it yet. It's going to be this machine. We're going to announce what ns1.cyberwater.com actually is later in the file. We add in the 1 there because typically you'd add 2. You'd have multiple DNS servers for failover reasons, redundancy, right? But we're not going to do that because there's not really a point if we're just here to teach. And again, you add the dot at the end. And then we're going to add in admin.cyberwater.com. This is actually an email. For starters, you just need an email. This isn't an email we've set up, so if anyone tries to send anything to it, it won't go anywhere. But we need to put something for the record. It's sort of forced in there. We're going to add in a smooth parentheses. And we're going to start defining the basic, we're going to be giving a few numbers to things about how long queries are going to last, how long they're going to live, how long they should last. So first is going to be the serial number. Typically, the serial number is going to be the year, month, day, and then just iterates 01, 02, 03. Because whenever that serial number changes, then and only then will the DNS record update itself. Because if you change everything in the zone file except the serial number, the DNS server actually isn't going to understand that the file has changed and it's never going to check itself there. So it's important to have it. And if we ever change it, we're just going to change what's there. And we'll mark it with a comment saying this is the serial number. Next, we're going to give the refresh number. This basically just tells upper level domain DNS services roughly how long it should expect it before checking in again on any queries it might have, because those upper level domain services, they're going to try and know where to point people to get to any specific domain. They need to know what those actual subdomains are, and so they'll communicate with each other. In this case, it's just telling it how often should you check in if you're not getting a response that you need. Retry is how long you should wait until you retry. Maybe the server is just a little bit slow. Once again, we'll hit retry to indicate it's retrying the retry value, but you'll give it some amount of time just in case the server is reacting a little bit slowly. You don't want it to be spamming our DNS server with requests when it's already struggling. Then we are going to give it an expiry. We'll give it a very long one. This is how long the record should last until it dies naturally. If it's older than this, literally just delete it. Ignore it. It's not real. Don't trust it. Ask us again. And then finally, negative time to live, which is basically if you get a response that's incorrect, how long should that last? Because it'll cache not just positive results, but also cache what it definitely isn't. And so this is defining how long that's going to last. And again, the values here are a little arbitrary. It depends on the purpose you'd give them, but in this case, negative TTL, we'll give it 1700, approximately 170,000. Now we're also going to end it before that comment. You don't technically have to. You could go further, but I don't know. This looks nicer. Be yourself. And we're going to reference the name server is going to be nameserver1.cyberwater.com, which we indicated was going to be the start of authority right up here. Here we're saying it's a name server of itself, of which it's the start of authority. And again, add that extra period at the end because it should technically be there. We're going to type in here, we're basically going to describe what's on the CyberWater domain. And we're going to start it by saying origin. This is just a reference to the computer itself. So it's referring to itself here, cyberwater.com. And once again, that extra period. Now we're just going to be naming what our domains are, what they should be, what they should look like. So the first one, that's going to be the name server 1. Again, this is an internet archive, and it's going to be what's known as a single A record. There's a bunch of different types of DNS records that DNS is going to carry. Some of them are single A. This refers to IPv4 IP addresses. So like if wikipedia.org is 218.208.192.7, that's a single A record. I'm sure wikipedia.org also has an IPv6 record. That would be a quadruple A. A. There is MX for mail exchanges. There's CNAME, which is basically more of an upper level domain that you wouldn't use often on a local network. There's a few others, but in this tutorial, we're only going to be tooling around with a single A record type because we're only dealing with IPv4 web addresses to web servers. So the first one, name server 1, again, that's defining our server right here, right now. This is the one. And so I got to remember what the IP address of the server was, which 192.168. .1.1. Anyone want to check me on that? If not, we can just check ourselves. We hit escape, we hit colon, WQ to write and quit, and then we issue IP space A for IP all. IP all tells us 192.168.2.1. All right, I'm glad I checked. We open that back up again. And it was what, .2.1? Once again, we hit I to enter insertion mode, .2.1. Now we're going to continue likewise for our shop. This is going to be an internet record type. It's going to be single A record. And I do not remember what the shop's IP address was. We'll check by just logging into our web development one. Again, this is just web dev 1. So this is the shop domain, the by CyberWater. It's 192.168.2.3. 192.168.2.3. And then we have what, the recipe? Recipe.cyberwater.com. Internet record type, single A, 192.168. And what was the other? I'm pretty sure we have it up on the web dev 1, or at least I do. .2.2. And that's all we're going to need. So we're going to hit escape, colon, WQ to write and quit. We hit enter, it's saved, it's written. Now when the name service tries looking for that file, it's going to exist. Now we're going to go back to that first file we were touching, the actual config file for the named service, because you'll remember we had that change me because we hadn't actually made the zone file yet. This is the file we're referring to. So named.conf, right? We use tab to autocomplete because it's faster, and we don't remember what's in there. I certainly forget. I have terrible memory. Zone, cyberwater.com. We're going to remove change me. First, we're going to get into insert mode because you can't delete otherwise, and change me to what's going to be / the root etc for files that change but not often / name d / cyberwater.com.zone. We hit escape. We hit colon to enter in command mode, WQ. All right. Now it's all configured. It should be running. And we can just bring up the try and bring up the DNS system and use it. So we're going to system control, system-ctl, start our named name server, domain name service, name daemon. Command not found. Incredible. I think that's because there's no dash in there. And here we're actually getting a failure, so we have to figure out why that is. I'm pretty sure it's because we have a syntax error in there somewhere. And as I said, there are commands to check that syntax error. Now, I actually don't remember what those commands are, so we're just going to very quickly look them up. John already has an idea. But literally, this is just, we do it all the time. Command to check syntax in bind zone files. Right. And the command to check syntax in bind 9 config files. So the first one, it's going to be named.checkconf. named-checkconf, right? And it tells us we're missing some things. So we got to check the conf. We can go back into vi/ect/named.conf. And what is it telling us? There's a missing semicolon on line 13 and an extra one on line 68. So let's check out line 13. Oh, here it is. Listen on port. You'll notice this 127.0.0.1 has its own semicolon after it. There's none after 192.168.2.0/24. So insert semicolon escape colon WQ. And we'll check that again. Missing semicolon before the end of the file at like line 60. I'm going to guess where that is. Oh, would you look at that? It's right there. We will need a semicolon right after the end of that parentheses. You'll see it in this zone file, in the logging file, all the other files. So we exit out of insertion mode after putting it in there, colon WQ. We run that again. not that command. We run name.checkconf again, gives us nothing. That means it's correct. Now let's see if it actually starts here. Now I'm using the up arrow right now to go back to old commands that I previously just had. We hit enter, and it does it without question. Now if we check system control status named D, it's up and running. So theoretically speaking, we should just be able to get into it. Not quite. We're actually, there's a host firewall on this machine that is going to be blocking any DNS communication because we haven't allowed it to. Host firewalls are firewalls that are placed on individual machines. So this would be, machine to machine. There's a bunch of different kinds of host firewalls, IP tables, UFW, which stands for uncomplicated firewall. Ours is going to be firewall-CMD. So if we just try and show it right here. Web dev 1. So first thing we do, we get back to the terminal. Now we do need to assign the DNS server as a DNS server. That's easy enough. Here we don't even need to use VI because Debian, unlike CentOS, will actually have good, easy to use, non-frustrating text editors such as Nano. And then we just, or you can still use VI if you want. I'm not going to stop you. So we go to nano/x/resolved.conf. Resolve D, meaning it's the resolve service, is daemon. This should have something in there. Give me a moment.
You might need root for that one. It said that it was not writable, or yeah.
That is correct. My apologies. So certain files have permissions on them at an individual layer that disallows unprivileged users from accessing, writing, or reading them. It's resolve.conf. Thank you, John. But we will need to elevate to the root user. Now, there's typically two ways to do that. The first is using superuser sudo, however you want to pronounce it. But unfortunately, our user isn't actually even on the what's known as a wheel, which basically just means what are the users that can invoke sudo? Our user, the default user I made when I first made this, isn't on there. So if we try to sudo nano/x/ what is it? Resolve.conf. It'll ask us for password so that we can invoke sudo. We try and give it our password, webdev1, and it tells us we're not in the super users file. We can't do this. So we're just going to need to switch to the root user su space. And then the password for the root user is, by coincidence, the same as our password because I said it that way because I don't want to remember all that many passwords for test environments. But you can see right now, we're not web dev, we are root. And now, when we try and nano/x/resolve.conf, you'll see this. You'll see a bunch of name servers. We have a name server. We have the DNS name server. So, name server, what was it? 192.168.1.2.2.1? Anyone remember?
2.1.
2.1, thank you. .2.1. We save that. As you'd expect, Control S saves it. And then we can hit Control X for exit. You'll see this write out. That's basically save, but slightly different. Nano is very nice. It's very friendly. A lot of people like it a lot more than VI or Vim, but I will not judge you for whatever text editor you use. So if we try and use it now by going to, say, shop.cyberwater.com, it's still not going to work. because that host firewall is blocking DNS queries. So we'll just go back and enable it. We're going to use this using the firewall-cmd commands, firewall command, because that's what we're using. Firewall-cmd, and we can start by just listing the firewall commands we have right now using this -- list all flag. Whenever you use Linux commands, a lot of the flags will be single letters, single dash. Sometimes it'll be slightly longer, and if it's longer than a single letter, it'll be 2 dashes. And we'll notice we got some things allowed. Services, DHCP v6 client and SSH. Neither of those are DNS. So we're going to have to add the DNS server. So firewall command, and I just hit the up arrow because I don't want to type that in again. And then we're going to do an add -service equals DNS. And again, to motivate this, we can just, if we didn't know that was a thing, we could check the man pages if we spell the command correctly. If we can spell the command correctly. And it'll tell us everything we need to know about this firewall system. So we'll hit Q to quit that. Clear out the terminal. It did say success. So if we do now, firewall list all, you'll notice DNS is on there. So we might be hopeful that we can just go back and refresh the page here and get to shop.cyberwater.com. But we can't, because that negative cache still exists. You'll remember that negative time to live? Well, it's remembering here that it was actually unsuccessful. So we'll go to what? Recipe.cyberwater.com. And we're still unable to get onto the service. Now, basic troubleshooting. John points out something very important. I actually haven't reloaded the firewall. So whenever we change a service like this, you basically just got to turn it off and on again. Firewall.cmd -- reload. Success. Okay. And we can test that connection using something known as netcat. Netcat is something that would expect another service on that side. We can test individual ports, so we can test the DNS services sort of special thing. So netcat, the 192.168.2.1, and we can specify specifically we want this on port 53, which is DNS's special thing. It's telling us there's no route to the host.
Can you try quick ping just to make sure that it's reachable with other tools?
Yeah, so ping is basically just sends out an ICMP echo packet request. And as you can see here, it basically just goes in and it responds. That's all it does. It's not very complex.
Okay,
Control
so
C.
it is live. That is weird.
So first thing you should always do, turn it off and on again. Dash power down, dash restart. And we'll set the time to 0. God damn it. We'll just do it manual. Yeah, so John sort of puts in the chat referencing service networking restart. That's something you can do to restart the networking environment, very similar to what we did with systemctl, system control for checking the status of the DNS server. So we'll just log in here. That way I wouldn't have had to go through the full reboot, but never a bad idea to turn it off and on again. We hop in, we open the terminal. We are going to change our configuration to the nano/x/resolve.conf. Name server 192.168.2.1.
Oh, you're not root again.
Thank you, John. David, sorry, my
No, you're
apologies.
good.
It's a little bit late here. We have to first get into sudo. Name server 192.168.2.1. And fingers crossed. shop.cyberwater.com. And I'm going to take a random stab in the dark and suggest that's not going to resolve, just given the length of time it's taking here, but we'll give it a moment. Check. Speed. And of course, that server's not found. Now, I have my suspicions about what's going on here, but let's check the journal. A journal is basically just a brief log to check what's going on with DNS, with any sort of services here. What would be the command for?
I believe it's journal CTL-XE, I think. Or yeah, yeah, -XE. E, not D, sorry. There you go.
All right, perfect. Now we see sort of at the end here, you can just quickly check in whatever the service specifically it's trying to go. And we see this name D, that's exactly the one we have. And we see these queries. Shop.cyberwater.com. Query is denied. So why is it denied? Good question. We exit out of this and we'll check our configuration there. So we check the /x/named.conf. We don't have nano. Yeah, absolutely. This is still all recorded. I do recognize we're going over time here, so I'll try and hurry it up. But absolutely no offense taken if you have to get out.
Oh, the listen on port, shouldn't that be 2.1?
Yes, yes, it should. So it seems we might have just been denying them. Again, if we want to be super, just actually no, we can't be super insecure. We cannot pursue YOLOSEC by commenting out listen on port 53 because the current iteration of bind actually defaults to just closing it off. But yeah, this should work. Everything else looks right. We're gonna hit escape, :WQ, and once again, we're gonna shut it off and on again. System, CTL. Restart. Named. Let's check the stats of named. It's running. Perfect. All right. Let's go to DNS Web 2, just so we don't have to worry about clearing the cache here. We're going to log in. Web dev 2. Give me Firefox. Wait for Firefox to load. Don't restore the session. We try to go to shop.cyberwater.com. Still not able to. We should be able to check the journal of specifically the DNS service. Let me check the man pages of journal CTL to check how to do that. All right, we can just check once again the .exe and look for named. We can see it start up here. Unit named .services finished starting up.
Oh,
The startup result is done.
Did you set up the resolve.conf in Web 2?
I did not set up the resolve.conf in Web 2. Thank you, David.
Yeah. Oh, good.
So we go to activities. You'll remember that was what we actually used to hit the name server, so to speak. So we get into the terminal. We nano.
No, wait,
/
slow down. Root.
We switch to root. Switch user. Web dev 2 and /resolve.com. Name server 192.168.2.1. We're going to hit Control O to write out, Control X to exit. And we'll go to recipe.cyberwater.com. Now, what we're using here is what's known as a dig command. Basically, just tells us certain things about a domain, or reverse if you'd like to. And when we try and query the network server number 1.cyberwater.com, we get an NX domain response. This means that the domain does not exist.
I'm wondering, do you want to go ahead and comment out our Google, our 8.8.8.8 and 1.1.1.1? I'm wondering
Yeah.
if it's trying to use those as more authoritative than it's
Well,
unlikely,
theoretically,
but I'm
yeah, I
wondering
mean,
if it is.
theoretically speaking, it just takes from whatever's higher in the list first.
Yeah.
Because there is actually an existing cyberwater.com out there. It's some random Taiwanese company trying to sell cyberwater, in case you're interested.
Okay, so it timed out. Huh. You want to go ahead and John had suggested
Yeah,
something.
can I just jump in really quickly? And if you go back to the DNS, this could be wrong, but it's going to bother me anyway. Because all right, and now just quit out of that, and then go back to named editing etc name.conf, and just go all the way down. And see how when you say allow query there, see how there's no spaces between the I think there should be a space before the one, yeah, and a space after the semicolon. I don't know if that's what's actually causing the issue, but I know named is super annoying like that.
There are quite a bit of services like that, especially in Linux. So
Yeah.
we're going to make that change. We're going to clear it.
We'll see if
And
that
we are
helps.
hopefully going to see.
The other thing I would do is use like check zone, named dash check zone on the actual zone file itself, and see if maybe there's something wrong with the zone file.
Yes, yeah. So that one of the things we looked up was that how to check the syntax of a zone file, named at check zone. And so we need to check the /zone file.
Yeah, you have to put the name of the zone too, I think, first. So it's going to be CyberHawks dot or cyberwater.com.
Cyberwater, John. Gotta get it right. Cyberwater.com.zone.
Okay, cool.
And it says it's all right. So
The moment of truth.
Yeah.
we'll dig. And it's looking like it's timing out again.
Yeah, I mean, we know they can reach each other.
I mean, I guess we didn't check if port 53 is open, but we did see
Yeah,
in
we
the
did.
logs that it was just denying some queries. So that makes me think that it can in fact reach it.
Maybe not. We can use netcat to essentially poke holes at ports. So in this case, 192.168.2.1's port 53, which is the one that DNS resides on. And we can see it's not coming up with anything. So actually, if we go to the DNS server itself, we're going to try to dig ourselves. ns1.cyberwater.com. And it loads correctly.
Oh,
Well, it's going to say NX domain because you didn't add the local host to your etc resolve.conf file in this machine. You know what I mean?
I believe we did with the $origin cyberwater.com.
No. I mean, like in the etc resolve.conf file on this machine itself, you don't have it like referencing itself as a name server. So you're not going to be able to look up local,
Yeah. I see what you're saying. My apologies.
No, you're good. And seriously, don't get discouraged. I have had so much trouble with bind 9 and getting it working, even in like the competition last year. Oh man, it was just solving silly little errors like these the whole time.
I appreciate the words of encouragement here. But if we dig here, we do see it correctly answers itself, which isn't much, but if we check for digging shop.cyberwater.com, it answers that correctly as well. We can see answer, authority, status, refused. Interesting. Journal control / exe. Why did it deny us? I'm almost worried here that we got something incorrect on the /x.
Check out the name.conf again.
Yeah. I'm worried we have something wrong with the listen on port. And we can change that to all queries, correct? Just to test this. Yeah. So for testing purposes, we're going to do something very insecure. Well, not that insecure, but we're essentially going to tell it to listen for everything. I'm not entirely sure. We'll check.
Yeah,
It might
looking at
just
one of
be
those
any-
answers, you can probably do 0.0.0.0/0, and that would do it on everything.
That is true. If
I
we're
think
using
any
CIDR note,
works as well.
Yeah.
CIDR notation, this is basically dating anything from the minimum of 0.0.0.0 to until you are swapping the 0th digit of this. So all IP addresses. So we exit out. We system control restart name D.
Maybe it didn't like that. Maybe I'm
Oh,
wrong.
not
the
like that.
semicolon.
Oh, the semicolon, yeah, the semicolon.
Semicolon, always the semicolons.
We love that.
Actually, I don't.
No, after the 0. Yeah.
Ta-da.
There we go.
Now let's dig it. Nope, still refused.
The second thing I want to try is that query that we modified before, that allow whatever that's on the bottom. What if you just get rid of it entirely and just allow it from everywhere? Will that fix it?
As in the sorry.
The allow dash query thing. I personally don't know how that works because I've never seen that, but
Well,
I'm just curious because that's another thing that could possibly be denying it if you
no,
all
allow query localhost. Go back up.
We'll see where, yeah.
You see this allow query that we had down here as well?
Yeah, okay, yeah. I think we got
Okay,
it.
well, we're gonna hit I to enter insert mode and O.O.O.O/24
No.
/0.
There you go. That works too.
WQ system ETL restart name D, and we're gonna dig ourselves.
Still no. Okay.
Still no.
Another option would be rather than at the bottom, rather than the 192, just put in any. So rather than that IP, it's just like literally the word any. And with the semicolon as well. And there's no space. There you go. Aha, no
And
error.
we see here it's not refused. It gives us shop.cyberwater.com, cyberwater.com, the name server, the no recipe server, interestingly enough, because we didn't ask for it. We just asked for the shop. We asked for recipe. All right. So we log into WebDev 2. We system restart networking.
System CTL, but yeah. And actually in Debian, you might have to restart the network manager. So system CTL restart capital N, capital M, network manager should do it. There you go. Now you should be good. Although you have to add it back to the etc resolve.conf file because of course network manager overrode it.
So we go in, we comment out all of these because we hate them. Name server 192.168.2.1. Save and exit. First, let's dig shop.cyberwater.com.
I mean, you also had problems with the netcat connection, so there might be an additional fire or firewall issue here going on that we haven't gotten to yet. You know, like I don't know if we can even. I mean, sorry, I mean on the like we can't
Yeah,
even
on
netcat
Proxmox.
from there to the DNS server, so we might not even be able to reach the DNS server on port 53. But I don't know.
Let's check again one more time, just the firewall commands here.
Yep, it's gone.
At one point, we restarted the service, and so now,
Yeah.
okay.
I bet when
all
you
right.
restart bind 9, it might. It doesn't make sense, but whatever. It disappeared.
Either way, we have a bit of a suspect here. So we just do add service DNS. Success.
And
Great.
actually, I think if you add -- permanent to the end of that one, it's never going to go away. I don't remember if it's to that or to the reload command, but I think it's to that.
That's correct.
there you
And
go.
then it's weird. If you do permanent, then you have to reload it. But when you don't add permanent, it just automatically does it. But reload was
That
fine
sounds
too.
right. That sounds right.
Okay, it's back. So hopefully it's good now. So oh
Start-
hey, look, there it is.
Oh, that's the recipe.cyberwater.com.
Let's
We
go.
did it.
Cyberwater.com.
Hooray. Good. All righty. You got a bonus debugging tutorial tonight to everybody.
Seriously.
I ran through this lab a few times on my own, and I did spend a solid like couple hours trying to debug something that ended up just being Debian needed to be restarted because of that negative cache. Sorry. As you can see, DNS can be quite complicated, just with so many minor mistakes. It's very important, but there's always a lot of things to check, to keep an eye on. And it's, always in the scoring circle, so easy to take down very subtly that You want to make it as secure as possible. Now, I do notice we are at, what's the time right now? 9:37, about 40 minutes past where we wanted to go. There are a few things on hardening that I would just like to touch on, but it's not necessary. We really covered a lot of some of the basics about what we're doing in the seminar already. Past that, it's just going to be a few sort of things to keep out for, things to understand. And so, might as well just run through a few very quick ones. First is a zone transfer attack. This is essentially, you can try and copy the zone, something known as a zone transfer. Basically, just bringing everything from DNS server 1 to DNS server 2, copy it over. It's done all the time because it's, you'll have DNS servers changing all the time for any number of reasons in a large organization. So it's very important to have a system of backups, of updates for local DNS, for large DNS, for global DNS. And we can exploit that if we don't protect it. So if you log into the Kali machine, bad guy. If it's bad guy. Should be bad guy. Interesting. Well, actually, we can run the attack from even a friendly web server. It's not a complex operation here. So if we do use that dig command again, there's a flag we can use, AXFR. It's basically just transfer the domain to me, tell me what's there, and we give the IP 192.168.2.1, cyberwater.com.
I think there's actually no dash before AXFR because dig is weird like that.
Dig is weird like that. That's messed up. All right, so cyberwater.com, it gives us a whole bunch of useful information if we're an attacker. It tells us, oh, look, there's a name server here. There's this recipe server that if we're public, we might not have known about, which might allow them to get a foot in the door with finding admin login pages, finding things. You shouldn't be hiding anything with that being your only defense, but you don't necessarily want people to even see your administrative login pages, which you might have separated from DNS or your IT support system or your HR system or your payroll system or whatever, right? You want to keep things separate as possible. If you ever want to stop that from happening, there is a zone transfer in that /x/conf. I'll just show it to you. Yeah. I might be on the wrong page here. But essentially, there's a way to disable zone transfers. My apologies, it's blanking on me right now. But we can stop that from happening so that the only way you can do a zone transfer is if you're from, for example, another IP on the network, one that we specifically assign. Sort of like how we did for listen on port 53 or allow query or anything like that. The second thing that we would probably do, or at the very least we should recognize, is the idea of least privilege as it relates to bind. Least privilege basically just means you have all the permissions you need to do your job and nothing else. In this case, it's done by the way bind works. It actually makes its own user called bind, named bind, sort of like how you have a user for yourself, your administrative accounts. It makes a fresh account called bind with not, it's no super user's permission, much like the one we have in web server. It can't call sudo. And we can actually further restrict that by change root. Essentially, we can change what its root file is. And so the root file, it's the top of the file system. If we go cd/ls, we see all the basics up here. But if we try and change to anything above that, we'll notice we're still in the same place, no matter how many times we try and go above the root, because root is the top. Can't go beyond the root. And so change root, you can change a user's root to, instead of being the actual root, be some other smaller root to sandbox them in, to keep them in there. And we can do that with the DNS user. If we find this, I believe it'd be vi/x/ the initialization daemon. So init-d. Binds 9. So this is whenever anything is initialized, this file is going to read what is it? Essentially, we can change the user's root directory in such a way that we can keep them restricted to a sandbox in which they have only what they need, only the specific folders. They'll have access to a trash can, some random number generators, and brief storage, basically to get anything you would need. /x/init-d/named. Unfortunately not. I am very sorry about this. I'm kind of a little bit unprepared here. Sorry. My apologies here. Essentially, we should be able to restrict a few things about the account, the user. I can go in, get a tutorial up soon enough. My apologies, I don't have it ready today here, but it appears I'm just a little unprepared. Beyond that, there's really not much that I think would be of strict importance. Is there any specific questions anyone would have relating to DNS or DNS setup? I'd imagine not then.
All righty. Well, thank you so much, Nick. I know it was we got, I guess, to put it on another, we got some good practice in with debugging, and that's, like John was also saying, that is not uncommon when dealing with DNS. So, but thank you very much for putting this together for us tonight. And then next week we have Ben, and he'll be doing some stuff with Kali Linux and doing some basic scanning. So with that, that's pretty much it for this evening. Thanks, everybody.